Aloha, 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 section 7.3, part 3, volumes of solids of revolution, the Washer method. Now, we're going to start taking notes in here, but I need you to get your own notes out because there's a way I'm going to introduce this that's going to be a little bit differently than some of these problems that you have here, okay? Now, the Washer method. What the heck is the Washer method? Well, it's kind of like when you have a disc and we cut that little donut ball out, that little munchkin. Why doesn't somebody bring in some munchkins? All right. Especially if you've asked me for a letter of rec. All right, here we go. So what the heck is the disk method, right? We've been revolving things about an axis, right? This we could say is revolving it about the x-axis. Now, if I were to take this rectangular object here and revolve it about the x-axis, what the heck would that bad boy look like? Now I've kind of been trying to practice this, okay? So let's see. It would look like kind of like this. Let's see how I do here. Okay, that would be like the bottom of it there. And then we would kind of have an inside, okay? Oh, snap. That's pretty solid. You try to see if you can do that well. But what would happen is we would create what we call a washer. Okay, class? Now, what happens if I said, what is the volume of this beautiful figure that I drew above? Now, that 3 represents that distance right there, okay, class? And of course, the pen marks out. Do you know why the pen went out? Because they want me to show you again how to draw that beautiful picture. All right, so you know what? Let's show you again. All right, so how do we draw that sweet bad boy? Let's see if I can do even a better job. Snap. Deppity-dep. Yeah. Sweet. All right, now how would I find the volume of that object up there? Well, it's kind of like we have, if we're looking at the cross sections, right, we have 2 circles. It's kind of like I have a big circle or a big disc, right? And it's kind of like I have a little disc. How about that? And how would I find the volume? Well, let's take the volume of the big one, which would be the area of a cross section, which would be pi. And it looks like it's a 5 plus an 8 right there, right? 5 plus 3, which would be 8. So it'd be radius squared times the thickness, right? That would give me the volume. Kind of makes sense, class? Now, if you look at the little guy, that guy has a radius of 3. So that would be the area of that cross section, which would be pi 3 squared times the area times that thickness. And those would give me the volumes of both of those. Now, does it make sense that if I take the volume of the big disk and subtract the little disk, then I would get the volume of that, what we would call a washer. And that's exactly what we would do here. And then if you notice kind of something else here, they both have a pi in it. So let's factor out that pi, and then you get this little fancy dude right there, right, class? And then guess what? We could even make up a little formula for this guy and make maybe that a capital R to mean the big disk, and that radius squared minus the little r. And that, believe it or not, if I kind of scroll up a little bit, that is our little formula, how we find the volume of an object if it involves what we call the washer method. So if I were to revolve things, remember we get things that are circular. It could be a disc. Now we're learning that it could actually be a washer. Now there's keys that you want to pay attention to when using the washer method. You need to write those out yourself. Now, how are you going to figure how to write those out? Well, we have a beautiful blank canvas here, and we're going to work on some problems, okay? And we're going to use that same example that we used for the disc, and I'm going to show you guys of why it ends up being a washer method today instead of a disc method, right? Homie, Holmes, Chicago Bulls start tonight. What's up, Kobe White? Shoot, 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 shoot. Bucket! All right, check it out. University of Hawaii Rainbows. All right, so here we go. Let's go y equals x squared again, right, class? We're going to still use that graph, okay? So we have y equals x squared. Booyah. Okay, we're going to stay in this first quadrant here. So if I want to stay in the first quadrant, let's say, let's make a line x equals 2. Okay, so we have x equals 2. So it's the area bounded by these regions. And let's go with the x-axis. Okay, the x-axis, or I could say y equals 0, right, class? And so on the area bounded by those regions, which would be this right here. Now, let's look at this very quickly. And I'm not going to draw all these, okay, class? But if I was to revolve this about the x-axis, okay, if I was to revolve it about the x-axis, you know what? I'm going to draw these. Let's revolve this about the x-axis. If I was to revolve this about the x-axis, boom, I get that. And if I was to draw a cross-section, right, class, I would get that. Booyah, booyah. Right, class? If you look there, that's a solid disc, right? That cross-section that I drew was completely filled in. Okay, class? Vice versa. Let's revolve it now about the y-axis, okay? And remember, I'm always going to draw in blue what it would look like. And I'm going to get that other half of the parabola. Okay, like that. All right, class? Now, let's go ahead and draw a cross-section for that bad boy. A cross-section would be, let's slice that. Oh, snap. Wow, look at that cross-section, huh? Well, if I look at that cross-section, class, it looks like not all of it is red or blue. And if it's not all red or blue, we get a cross-section that ends up being a washer. Now, check this out. If it ends up being a washer, I want to draw a washer. There's my washer. Okay, I'm going to have an outside, and I'm going to have a big circle and a little circle. And we're going to use that formula that we had for the volume whenever we have something that creates a washer. And what was that formula? It was volume equals pi, the integral, from a to b of pi, capital R squared minus little r squared. And then it could be a dx or a dy. In this particular situation, I'm perpendicular, right? Those cross sections are perpendicular to the y-axis. So for this one, it would be dy. Okay, so now I just have to really focus on what is the big R and what is the little r. So I kind of encourage students to do this. Let's go over to the side and let's write a big R and let's write a little r. And if I'm able to do that, hey, easy peasy, Japonesey, right? All right, well, what's the big R? Well, let's draw the big R's. And the big R goes from one end all the way to the other, right? Right to left, right to left. Well, if I do right to left, then hey, I'm going to find the radius of that, right? And it has to be in the red part. And the radius of that in the red part for the capital R would be the right, and the right happens to be the 2, minus the left, which happens to be 0. So it would be 2. And if you notice, that is a constant, right? 2 is a constant. And the reason why it's constant is because that radius for the big disk is always the same, right, class? Kind of interesting how that works out. Now, I'm going to, I can't erase that. So what I'm going to do is I'm going to use this disgusting green color, and I'm now going to draw the inner. So it's like, let's say all that was shaded in, right? I would have a complete disk. But now what I'm going to do is I'm going to cut out that hole, right, and bring that donut ball or that munchkin in for Mr. Tanaka. And so what I'm going to do is I'm going to subtract that green dude. Now that varies, right? That varies. Depends where I'm at, it varies. But guess what? The radius of that would still be right minus left. Well, what is the right? The right ends up being the curve. Now, what is the curve? Well, the curve has to be in terms of y's. So we've already done this one, so we know it's the square root of y when we're in the first quadrant. If you don't like that color, too bad. Okay, but the right side would be the square root of y, and the right side, the left side would be 0. So that's just the square root of y. So how do I finish this problem? It says, okay, as this class, the volume is equal to the integral. It's all have to be in terms of y's, right? Why? Because all of these washers are perpendicular to the y-axis. So it's going to be from y equals 0. Ooh, it's not 2, but I go all the way up to 2 squared, which would be 4. Okay, and it's going to be pi. Pi is a constant, so let's just bring that bad boy out already. And then it's just capital R squared, which would be 2 squared, minus the little r squared, which would be the square root of y squared dy. Well, let's check that bad boy out. Okay, so that'd be the volume equals, let's simplify that. There, we got a pi there. We're going to go from 0 to 4. 2 squared is 4. And then the square root of y squared is booyah. Oh, I can do that by hand. What's up? Okay, right, so that'd be antiderivative 4y minus 1/2 y squared. I'm going to evaluate that from 0 to 4. The zeros would cancel out, right, class? What do we get? 16 minus 16 over 2, that'd be 8. And then, well, I guess let's not take the shortcut, right? Boom, 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 boom. Okay, and so I get an answer of 8 pi. How about it? Not bad, huh, class? Not bad. But I hope you understand why that turned into a washer instead of a disk, right? If I revolve that about the x-axis, I get these disks. It's all filled in, right? Red and blue, all filled in. But if I revolve it about the y-axis, I get these disks that aren't all filled in. Thus, it creates a washer. Okay? All right. Let's get rid of this bad boy. And you know what? It's so fun. Let's try another one. Okay? So here we go. Let's draw this guy. Guess what? Same thing. Same thing. There's something else I could do, though. All right, so let's check it out. Oh, you know what? I know what I'm doing already. I might need a little bit more room. Right, class? I might need a little bit more room. Well, I've been using red. Why change it up now? What you doing? What you doing? All right, here we go. So it's y equals, same thing, right, class? We're going y equals x squared. We're doing x equals 2. And we're doing y equals 0. Right, class? And that would give me this right here. Now, let's see. What else could I revolve this about and get a disk? Hopefully, you're all over it. Well, if I revolve it about the line x equals 2, I would get a disk. Now, why would I get a disk? Because if I drew what it looked like, right, class? If I drew what it looked like and took cross sections, oh, it's all red and it's all blue. Well, if that happens, that's definitely a disk problem, right, class? Which is just pi r squared. And remember, the radius for that would be right minus left, right? You always have to use the red. Okay, class? But that'd be perpendicular to the y, so it would be all in terms of y's. You might want to practice that if you're not so good at it. All right, here we go. But what else? What other type of question could I get here where I would get a washer method? Well, it's if we revolved it about the line y equals 4. Okay, and if I revolve it about that line, okay, try to disregard this blue now. I'm going to make my new blue. And if I revolved it, spun it like crazy, you get something that kind of looked like this. Right, class? Kind of get something that looked like this. And it's important to be able to draw these guys, because when you draw them and then draw a cross section, oh, some of it is white. Right, homes? Some of it is white. And if some of it is white, that means we use the washer method. Okay, so I got to use the washer method. So instantly when I say washer method, I should write down volume is equal to the integral. Let's bring out that pi, right? From a to b of capital R squared minus little r squared. And you know what? Let's fill in first what we need here. It helps me to stay focused on what variable I need to be concerned with. Boom, there it is. We revolved it about that line. That looks like it's perpendicular, right? It cuts the x-axis. So that means everything has to be in terms of x's. Okay, so now I just got to do a little bit of side work and then I am good to go. What is capital R? What is little r? All right, to know what capital R is, let's draw some capital R's. It just goes from the end to the end. That's the big dude, right? That looks like a big disk to me. And if I look at that disk, I got to find the radius. Now, for the radius, what do I use at home? The red or the blue? I use the red because the red was the original drawing of the region that I was focusing on. And so that red would be the top minus the bottom, right? Because I'm perpendicular to the x-axis. Top minus bottom would be 4 minus 0. Oh, sweet. It's a constant. Does it make sense that it's constant? For sure, right? Because every single one of those big disks is constant. It's the same exact one. Now, let's use our cool, snazzy lime green dude. And if I drew it from the inside to the inside, which is the smaller disk, oh, snap. They vary. If they vary, it's got to have a variable, right? And if it varies, then I'm using the red. And if I'm using the red, it's the top minus the bottom, right? That would be the radius, top minus the bottom. And the top is 4, and the bottom is the curve, and the curve is in terms of x's already. Booyah! So there's the little one, there's the big one. All right, let's fill in our sweet little formula here. And we got volume equals pi. Everything has to be in terms of x's. So we're x equals 0. Oh, there's no way. It ran out, and I don't have my little pen. Can I use it on here? Let's check it out. Not even close. But it's going to be x equals, let's see if I can fill it in, x equals 0 to, what are we going to x equals 0, and we're going from left to right, right? That's how we're drawing our washers. So it's from 0 to 2, okay, parentheses, of your big R squared, which would be 4 squared, minus your little r squared, which would be 4 minus x squared. Somebody took my pen. Squared, and then it's times the thickness, right? And then That'd be a lot to do by hand, but you could do it. But let's practice real quickly. Put that in your calculator and let's see if we get the same answer. And if you did an amazing job, you never put pi in your calculator, okay? And you always math frac it, okay? But so make sure you're practicing this. But you should get 224 over 15 pi. Okay, sweet. Now what we're going to do here is we're going to just do a couple more washer ones. I'm going to make it a little cray-cray, all right, a little crazier, and we're going to make it a little bit tougher. And what I want you to challenge to do at home to see how much you're grasping it is to hit pause and do the problem before I get done, okay? Let's get a new, fresh, blank screen. All right, so challenge yourself right now, right, class? It's a lot more fun if you challenge yourself. Now, some of you are probably saying, well, Mr. Shinaka, we're just going to do the same problem over and over again. Okay, fine. Well, let's do a little something different. Let's go y equals the square root of x. Let's look at the region. Let's go y equals 2. And let's go with x equals 0. Okay, and let's graph that region. Okay, and I'm going to make mine in red because that's what we have been doing. And the red we never touch, right? So we have the square root of x graph, which looks like that. We have y equals 2, which is this line right here, right? That'd be y equals 2 and y equals the square root of x. And we have x equals 0, which happens to be the y-axis. So boom, there is our region. Now I'm going to make it a little bit tougher on you guys right now at home, okay? And I really challenge you to see if you can get the right answer on your own. All right, but we are going to revolve this bad boy about the line y equals -2. Oh, snap. What the heck would happen? One of the toughest things is knowing what the picture looks like. So hit pause and see if you can get the same picture that I am about to draw. All right, so it's 2 away there. So it's got to be 2 away there. So I hope you guys did actually challenge yourselves and see if you could draw this picture accurately. And then it's kind of 4 away all the way up there. So I would have kind of something, right, class, that looked like that. Does that kind of make sense? If I revolved it like crazy, you get a kind of like a cool little skate ramp, huh? If you did that, or a little half pipe thing going on, right? That's the shape we would get if we revolved it like crazy, right, Holmes? All right. And then after I draw the picture, what do I want to do, class? I want to draw a cross section. Boom. Oh, snap. That's definitely not the disc method. That's the washer method. How do I know that again? Because when I drew a cross section, it's not all shaded in, right? I've got a lot of white in there. That would mean the washer method. Hit that pause button. Challenge yourself right now. Let's go. Give me them toes. All right. So I really hope you guys are trying this on your own. All right. So what do I do now? Now I go ahead and I write down my washer formula, which is volume equals pi times the integral. We're going to go from A to B. Right? It's capital R squared. That's the big disk, right? And then I'm going to cut out that little disk. Give me some munchkins. All right, and then this is the most important thing. What goes there? Is it a dx or a dy? There we go. It's cutting the x-axis, perpendicular to the x-axis, which means everything has to be in terms of x's. Right, class? All right, so now I got to do a little side work. What's my big radius? What's my little one? Well, let's do the big one. Draw a couple of them. Oh, snap. It's the same thing every time. Well, that means it's going to be a constant and not have a variable in it, right, class? But how do I figure it out? Well, I've said it all along. You use the red. Okay, so if I'm using the red, I've got to use the red part. That's the top minus the bottom. Ooh, top minus bottom. What do we get there? So I got a little 2 minus a -2. Oh, snap. That's 2 negatives makes a positive, right? And I get 4. So, okay, I got a radius of 4. That kind of makes sense, right? If I were to draw that picture correctly, it's top minus bottom, right, class? Okay, I'm good to go. So now let's use our sweet, cool lime green color, and let's go inside to inside, right? That's what I'm going to cut out. Inside to inside. Oh, snap, it varies. Better have a variable in it. Better have a variable of an x in it since it's dx, right, class? And I go top minus bottom. Ooh, the top of that is the curve. So what is the curve? And it's got to be in terms of x's. Well, that would be the square root of x. And the bottom would be minus a -2. How about it? If you were able to do this on your own, just so impressive. And you know what? If you were able to do it on your own, kudos for you challenging yourself. And you're just going to get that much better at AP Calc. Okay, so I hope you guys did. All right, so how do I finish this, guys? So it's equals, right? Pi. All right, it's got to be in terms of x's. So x equals, what are we? We go from 0 And we go from 0 to what? Oh, I said x equals, y equals 2. Oh, no. Oh, no. I just noticed it can't be y equals 2. Well, it can be y equals 2, but then I got to change some things, right, class? I mean by this right here. I made it right there. Shame on me. Should we just fix it real quickly? Let's fix it real quickly. That's got to be a 4. Okay, just put a 4 right there in your notes. Now, why is it? Oh, no, snap. I am so good I'm on top of it. What are you doing? Can I erase that? Maybe I can. I might be able to go back, right? But if y is 2, that means x goes to 4. That's why I thought I was wrong for a moment. No, I'm not. I'm on top of it. And then what is my capital R squared? That would be 4 squared minus your little r squared, which would be the square root of x plus 2 squared. And then we do a little dx. And then what is your job right now? Is to make sure you're able to use your calculator. So let's go. Let's go ahead and math 9 that bad boy and see if we get the same answer. All right, my math frac didn't work for that bad boy, so I get 18.667 pi. Remember, don't put pi in there. We like to be as exact as possible. Could you do all these by hand? Yes, you could, and then you would get a fraction, okay? But you'll have some on your test that will be calculator, some that will be non-calculator, okay? Let's do one more. Come on, do this one entirely on your own. Challenge yourself. All right, let's go ahead and use that same picture, okay? So if I use that same picture, we're going to use booyah, booyah, booyah. So we have once again, I'll put it up there so you guys have it all here complete in your notes. So we're y equals the square root of x. We are y equals 2, and we are x equals 0, or the y-axis, right? The region's bounded by that. Now, let's see, what should we do here? Let's make a different type of shape here. Let's go and revolve this about, let's go y equals -2. Y snap. We just did that one. X equals -2, right? And so if it's x equals -2, what would I look like? It's 2 away there, so it's got to be 2 away there, right, class? And then there we go. So if we drew it, ooh, I'm running out of space. How about it going into the other side? And I get a little region like that. That'd be a cool shape. Look at what that would create, right, class, if I revolve that bad boy. Okay, let's draw one cross section. Actually, hit pause. Do it on your own. Okay. We're going to draw one cross section. Oh, how about this? This time the big one is varying. But it's definitely a washer. So here we go. Volume equals pi a to b. So washer, so it's capital R squared minus little r squared. What is that, dude? Well, we're revolving it there. That's perpendicular, right? It cuts the y-axis. So that means everything has to be in terms of y's, which means eventually that has to be in terms of y's. If that's in terms of y's, I'm going to use that bad boy right there. And then I just got to do a little side work. And I got a little capital R and a little r. But look at that capital R. It is varying. Okay, but to get the radius, I always use the red part, which would be the right minus the left. Well, the right is the curve, and the curve in terms of y's is y squared minus, so it's the right minus the left. What was left? The left was -2. Oh, snap, 2 negatives makes a positive. There we go. That's the big radius. Now, look at what happens for our cool greener. If I use this green guy, oh, little guy. Oh, dude, this time the little dude is constant. How about that? And so I would go right minus left, which would be 0 minus -2, which is 2 negatives makes a positive, and we got a 2. So now we fill in our little bad boy up there, and we have the volume is equal to pi, right? Always keep that on the outside. This time everything's in terms of y's, so we go from 0 all the way up to, what was it? We go all the way up to 2. Don't make a mistake with that. And then we have capital R. So this time this guy comes first. Y squared plus 2. We're going to square that minus the little r squared, which would be 2 squared, which is thump. Okay, put that bad boy. This would be an okay one to not use a calculator. But let's use our trusty little calculator and see if we get the same answer. How about it? I math fracked that bad boy, and I got 256 over 15 pi. Did you guys get that? I really hope you got that on your own. Well, that's under 25 minutes washer method, which could be a real difficult topic for everybody, even home. Can you make a bucket with all buckets? All right. Aloha. I'll see you in class. You have the rest of this bad boy. Okay. That I would love it if you took the time to see if you can get all of those correct. Shell method is going to be the next video. That's a BC topic only. AB, we are pow. Aloha.